Good afternoon, everyone, and thank you for joining us today for this Solve It session webinar. My name is Rachel, joining us from Belzona's marketing department.
My name is Daniel, and I'm joining you from the engineering department.
And in today's webinar, we're looking at two very similar applications, Chocking and Shimming, which have some crucial differences. We'll be examining case studies from around the world, looking at videos, and then in about 20 minutes, we'll have a Q&A session with our special guest, Henry Smith, Engineering Supervisor here at Belzona. So if you do have any questions throughout the presentation, please just type them into the chat and then we'll get to them at the end. So we have several things to cover today, starting with what is exactly the difference between chocking and shimming, just to clarify the two. Then we'll be moving on to chocking. We're looking at what damage mechanisms cause chocking and how can you negate that damage. We'll also be venturing to the chocking compound, Belzona 7111, was chosen to secure machinery into place. Then we are shimmying on over to shimming. We'll look at why we need to shim, what are the traditional methods used, and what advantages or disadvantages do polymeric materials have over them. Again, we're looking at case studies on new and old equipment. And finally, we'll move on to our Q&A session. So Dan and Henry are ready and waiting for your questions. So if you want to ask anything, you can either type it into the public chat or directly to us. But without further ado, I'm going to pass you over to Daniel, who's going to tell us all about one of his favourite topics.
Thank you very much. Good morning, good afternoon. As Rachel mentioned, what we want to start with is what's the difference between shimming and chocking. So they're very similar applications, but there's a few nuanced differences in there. Shimming is effectively just filling a gap. So this can be for a variety of different reasons, whether it's to create a closer fit, change the clearance, account for a manufacturing defect, or most likely the equipment's just been in service for a long time and wears cause some of the components to wear away and lead to misalignment and misfitting of different parts. Chocking, on the other hand, is essentially a shimming application, but with a very specific goal. So the aim of a chock is to make the base plate of machinery a monolithic member with its foundations. So what that means in layman's terms is we want complete contact and load transfer between the machinery and the foundations to reduce the vibration and the chance of damage to the machine as a result. So let's look at this in a bit more detail. Like we said there, it's a more specific application, but let's first look at why it's needed. So generally, large vibrating machines will be placed on concrete foundations, and without an effective chock, the vibration and impact will begin to loosen these foundations, which can lead to misalignment, the bolts, and in the absolute worst case scenario, which is unlikely, it could even completely shift off of its foundations, which would be rather catastrophic.
Absolutely.
But what are your options to ensure you've still got an effective chock there, or if you need to replace the one that's already been in place? You can use various types of gravel and gas expansive inorganic ones or cementitious ones. These both have the respective benefits and drawbacks. So iron-filled grouts may be liable to corrosion. Cementitious grouts quite often lack the chemical resistance required for some environments, although they still have excellent compressive properties. But one of the more popular options currently on the market is to use polymeric materials. And as you might expect, this is where you will find the Belzona solution. So Belzona 7111, this is our pourable chocking compound, and it's specifically formulated for this purpose. So it's designed to withstand the physical and thermal shock you'd expect in these kind of environments. It's got a very high compressive strength, excellent impact and vibration resistance, and it also has excellent creep properties. The material itself to use, it's a two-part 100% solids epoxy, and it has all the usual ease of application you'd expect from a Belzona material. So not only is it pourable, but it's also self-leveling. So this means you can pour it from one corner of your chock and it will flow into all the different areas on its own without any need for the applicator to nudge it in the right direction, if you like. So this not only makes it easier for the applicator, but it also means there's no need to completely remove the equipment before you want to install the chock. So what I'll do now is pass you back over to Rachel, who's going to take you through an example of where we've used this material before.
That I am. We're going to look at our first case study, which is from Peru. So this took place on a boat for a fishing company within the engine and machine room. And after some maintenance on the main engine, it was found that the system needed aligning and some machinery required chocks. Belzona 7111 was chosen as the ideal solution. The alignment tolerances between the engine and gearbox were very stringent, so it was essential that chosen product would meet these. So this was the first of two applications that took place on the main engine base of the boat's propulsion system. Here, 4 chocks were necessary to guarantee alignment. The chocks were needed to comply with marine certification norms as well, which Belzona 7111 was able to provide. Here you can see one of 4 casings where the system was poured. Pouring was seen as a quick and easy application versus manufacturing expensive new shims. As well as this, the fishing company felt that metal shims didn't guarantee 100% support, and therefore would need further corrections. All of this would result in days of downtime, no production, and a great financial loss, whereas the cured Belzona 7111 would guarantee support, averting these issues. Then, once the propulsion system had been aligned, the reduction gearbox also needed chocking. For this application, Belzona 7111's compressor strength was necessary, so despite the weight of the gearbox and the high torque applied to the anchor bolts, it would not change in height. This application saw 2 dams being filled. Then, following on from the pour and cure, the engine was supported and the anchor bolts were tightened. And after this, Belzona 7111 was found to be level up to 1,000th of an inch, which was completely acceptable and safe for alignment. So all of these applications were very successful, and all in all, the boat's maintenance team found that the Belzona system had a lower cost than other chocking materials on the market, yet provided perfect results, and overall they were very happy. So as I mentioned earlier, one of the reasons Belzona 7111 was chosen for this application was because of the host of approvals it holds, as you can see on the screen.
The other thing to mention here as well is the application. So some manufacturers may stipulate that they have to design and apply the chock themselves. That's not the case with Belzona, so you can apply this yourself. We can provide training for that. Or if you don't want to do that, there are various contracting arms, so we have our own one. But obviously it depends where in the world you are with contractors, but ultimately anyone can apply this material with the correct training. I suppose the only question now though is, how do you actually apply it? Which I believe we might have a video for you that will explain. So, as we mentioned at the top, shimming is a much broader category although the basic principle is still very simple. We want to fill a gap. So reasons that we may have a gap that requires filling. The most common cause is wear, so whether this is two components rubbing against each other, resulting in a loss of material, or general wear and tear causing things like keyways and slots to become misshapen. Another common cause, especially on concrete substrates, is chemical and environmental wear. So chemical attack or moisture in the air or freeze thaw action can cause things like this concrete tank, the plinths here, to wear away and essentially misalign that tank. Or in some cases, it can again be a manufacturing defect or oversight where you're too far down the line to go back and completely redesign the equipment so a shim may do the job at that time. So the results of not correctly shimming, again, is very similar to chocking. So the biggest one is normally misalignment. So if it's out of line or not as it was designed, this means you can have stress concentrations where you weren't intending to have them. Ultimately, the worst case scenario is that could lead to failure of the equipment, and that also taps into the poor load transfer there as well. Another issue could be crevice corrosion or galvanic corrosion. If you have very small gaps where you haven't got 100% contact between two different materials, moisture can get in there and cause accelerated corrosion. So what are your options for creating a shim or repairing something like this? The most common one, obviously, is a metallic shim. So this can be things as simple as a washer, all the way up to really high tolerance machined metallic shims that are bespoke for a certain application. And obviously the issue with that is the amount of machine time, and if it's a slightly irregular shape and you're not sure exactly what the dimensions are, it's very difficult to create a metallic shim that will have complete contact there. In some cases, you can use cementitious repair materials. So if it's the case that we've got on the picture there, you could use a cementitious material to place it underneath the plinth, rebuild it and give it some strength back. Generally, the issue you've got there is if it is concrete based, you're going to have the same issues as you had before, and it's likely to still wear away in the future. Or, as you might be noticing the theme, you have a third option, which is polymeric materials. Now, in this case, there's quite a few different materials you could use. It's not like chocking where there's only one material. There's a vast range of materials you could use. So we're just going to take you through a few here. The first one, as ever, is Belzona 1111, the workhorse of the Belzona range. It's a two-part epoxy paste grade, very durable, fully machinable, and very versatile material.
Next, there's Belzona 1321, which is a ceramic-filled epoxy that has outstanding compressive strength, making it perfect for shimming. It will bond to almost any rigid surface and then provide some serious erosion and corrosion resistance.
Then the third one we've got here is Belzona 5811. So like 1321, this is a fluid grade as well. Again, this is very versatile, multi-purpose. The key thing for me, anyway, with Belzona 5811 is its application properties. It's a very nice, easy material to use, but it's still got all the mechanical strength that you'd require from one of these applications.
And finally, we have Belzona 4111. So this is the after picture from that one from the previous slide, and as you can see, by using Belzona 4111 as a shim, it's provided a much needed solid foundation to this process vessel heel. Belzona 4111 is an epoxy repair composite designed for the repair, resurfacing and protection of concrete and stone. As Dan said, these aren't our only materials which can be used to shim, just some of the most popular.
So you can see here, these are some of the benefits of using Belzona materials over some of your more traditional methods. The key ones there at the front, they're all cold applied. All these materials will cure on their own without any need for hot work, and there's no solvents because they're all 100% solid. So not only is that safer, but also it means when you're forming, you can use the original equipment and it's not going to change shape while it cures. So you know you've got exactly the right shape. They're all easily applied, like most of our materials, and the other key thing to say here is these are long-term solutions and not just quick fixes. So we've seen here there's a variety of different materials that can be used for irregular shimming, and this results in a few different ways of creating an irregular shim. So broadly, we could split it into two different categories. You can create them by hand, either troweling the material into place or using shuttering and formers to make an effective shim. Or for particularly difficult areas or large voids, you could use the fluid grades to inject into a cavity. And generally, these shimming applications will occur as part of a larger Belzona application. I believe now Oh, so we've got that picture again. And now Rachel is going to take you through a few examples of where we've done some irregular shimming before.
We're going to go on to our second case study of the day, and this was at a food processing plant in France. So here, the concrete within this chemical containment area had experienced some heavy deterioration, and this was due to leakage during maintenance operations, and the integrity of the structure was compromised. So therefore, it was decided to shim the area using Belzona 4111 and then coat the whole area with Belzona 4311, which is a chemical resistant coating. Here you can see the completed application, and the plant engineers found the repairs to be very easy to carry out, and the whole area was brought to standard to meet the required regulations. Plus, this has proven itself to be a very durable repair. An inspection 6 years later after the application found that the containment area was found to be in absolutely perfect condition. And the following case study took place at a central processing facility in South Korea. This was a massive application where Belzona 1111 and 1321 were used to shim some risers and riser housing. So to really give you an idea of the scale of the job, we created a little video to show it off. So we're going to roll the clip.
There we go. Okay, so it was found on these large risers at the facility that they were moving inside their housings that you can see there. So the decision was to take to bond composite bearings into place to try and eliminate that movement. So Belzona 1111 and Belzona 1321 were used to bond the bearings in place, but at the same time as bonding them in place, the fluid nature of 1321 meant it would go and fill all the small cavities and act as an irregular shim. So it's not always going to be two perfect circles meeting. So any microscopic areas where there wasn't perfect 100% contact will be taken up by the fluid Belzona. So using this method, we not only bond the bearings in place, but because we've completely sealed it, it will also serve as a corrosion barrier. So in total, there were 84 risers and housings completed on the hull side and 27 on the top side. So Belzona was able to offer the products and the technical support to help with the design and installation of all of these risers.
If you're interested in more Belzona videos, you can always check out our YouTube channel, which is youtube.com/Belzona TV. We have hundreds of videos on there, and they're a great visual way to see how to apply Belzona and learn more about our materials. So to give you an idea of some of the videos on there, we have our how-to series where we show you how to do specific Belzona applications, such as how to repair cracked machinery or repair damaged overhead concrete, how to stop a live leak, all sorts of applications. We have our Put It to the Test series, where in these videos we compare Belzona materials to their traditional counterparts in a more visual way. As you can see here, on the left is concrete and on the right is our Belzona material. We have different product and application videos where we focus on specific products and really showcase their benefits. And finally, we have some introductory videos. So if you're new to the company, you can check out these videos, and they just give a great general overview of everything we do. And many of these videos are also available in numerous languages.
So as we've hopefully shown you here in these past 20 minutes, chocking and shimming is an extremely varied set of applications, even though the basic principle is very simple. So the need for an irregular shim or a chock can appear at any time in many different situations, but luckily we have many different materials that can be used in a variety of different ways to overcome these difficulties.
So if you have any questions, if you could type them into the chat now. As Dan was saying, we hope we've given you a good overview of our solutions. But if you want any more information after the Q&A session, you can check out our website. There you'll find links to your local Belzona distributor, and as you can see by the map, we are well represented all around the world. But regardless of whether there's a little flag in your country, there'll always be someone dedicated to helping your region with our materials. But without further ado, I'm going to pass you over to Dan and Henry, and we're going to start the Q&A session. So we've already had one question, which is, how do you prepare the surface adequately before chocking?
Would you? They've had my voice for a little while, so you can take it.
Yeah. So in order to do surface prep, it depends on whether that thing you're chocking needs to be removed at a later stage. Obviously, you don't want to grip blast and get optimal prep and bond it to the surface if that engine, that machine needs to be picked up and moved somewhere else at a later date. So all we're looking for really is a clean surface to apply the material onto. If you want it to bond, then mechanical preparation, grinders, grip blasting, that sort of thing. But it depends entirely on what the customer or the client wants at the end of the day.
We have the question, can you use materials other than Belzona 7111 for chocking?
Yes, you can, is the simple answer. So it depends, again, on the needs of the client or the job at hand. So if they require approvals from various marine societies, then it'd have to be Belzona 7111, as that's got those approvals. Generally, if it's chocking, as we mentioned in the webinar, it's more of a specific application. So normally you'd naturally end up at 7111 anyway, because it's got all the right properties. But no, it doesn't have to exclusively be 7111.
Yeah, so you could use a product like Belzona 5811 or 1321. Most of the coatings have good, solid compressive strength. As Dan said, 7111 is designed for that purpose specifically.
What kind of working life do we have for Belzona 7111?
Depends on temperature.
It does depend on temperature.
Can you remember off
the top of my head, I think it's approximately half an hour at 20
Yeah.
degrees. It's the standard we tend to follow. Obviously, if it's warmer, that reduces your working life. If it's colder, that extends your working life. Again, it depends entirely on where in the world you are applying the material.
Yeah, they're Celsius temperatures as well, 20 degrees Celsius.
Yeah, sorry.
Do we know that in
hmm?
Fahrenheit?
I don't know the conversion from 20 to Fahrenheit off the top of my head.
The next question is, how long does Belzona 7111 take to cure? And are there limitations for minimum and maximum thickness?
So maybe the cure time. The cure time at 20 degrees Celsius is 24 hours, I believe. Every 10 degrees you go up, that halves. Every 10 degrees you go down, that doubles. So at 10 degrees Celsius, it's going to be 48 hours or 2 days to cure. Do you know what the limits are?
There are limits. I can't. Go on, you tell me.
Yeah,
Just
so
in case
the
I
minimum
think I
thickness we're
remember.
looking for is 12 millimeters, and the maximum for 7111 specifically is 100 millimeters in one pour. Doesn't mean you can't do more than one, but for one chock, one pour, 100 is the absolute max, 12 is the minimum.
If there's any more questions, you could type them into the chat now. Otherwise, we will finish up. Thank you, everyone, for watching. It's been a good webinar.
It's been fun.
It
I enjoyed it.
Yeah, so I'm going to assume there's no more questions. So cheers for that, everyone, and we'll see you next month for our next webinar, which will be on chemical resistant coatings.
Thank you guys.
Okay, bye.